Over the next century, the UK will generate more than 600,000 metre cubed of radioactive waste, more than enough to fill Wembley Stadium. This radioactive waste will cost more than £100 billion to safely treat, store and dispose. This is an incredibly complex social, technical and economic challenge. Here at the University of Sheffield, we're working on developing the technology to transform our most hazardous and long-lived radioactive waste into a stable glass. So why do we choose glass for radioactive waste? Well, radioactive waste contains almost every element in the periodic table. Glass has an amazingly flexible structure, and it can incorporate those elements and bind them very strongly into the structure, so they're very hard to dissolve out. So in combination with its excellent chemical durability, glass is also very radiation tolerant, and those two properties make it the material of choice.
At Sellafield, they take nuclear waste, which looks a little bit like this simulant that we've made. It's dissolved in nitric acid, and it's dried into a powder and then mixed with a borosilicate glass frit. This is melted together and it forms a black glass like this. At Sheffield, we make our own non-radioactive version of this glass. We mix together the powder and the glass frit, we melt it in a furnace, and then we pour it. And we can use this glass for experiments to try and understand its properties, for example, its resistance to radiation damage and its long-term durability.
One technology we're developing is hot isostatic pressing. This allows us to treat radioactive waste in a sealed can to produce a durable glass or ceramic material. The advantage of this process is that there are no radioactive emissions during the course of processing, and we can produce the minimum volume of packaged waste possible. One application of this process, potentially, is to treat the 140-tonne stockpile of plutonium present at Sellafield. And to do that, we're currently moving from this experimental scale to full-size packages, as you see here.
One of the most important properties of nuclear waste is its long-term durability. This is because the waste will be radioactive for over 100,000 years, and it will be disposed of deep underground, several hundreds of metres below the Earth's surface. Here it will be isolated from future populations and the environment until it's safe. In this underground facility, we don't want the waste to dissolve in groundwater and for the radioactive elements to be released to the environment, so we need to use a material that's really durable. We know that this piece of glass has been sat at the bottom of the sea floor for over 200 years and it's hardly changed its shape. Also, these glass vessels are over 4,000 years old, and although you can see some corrosion on the outside, they still retain their original shape. And this really goes to show that glass is a very durable material, and that's what makes it suitable for use in nuclear waste.
The first man-made glasses are many thousands of years old, and the glasses we're making today for radioactive waste immobilisation will need to last many hundreds of thousands of years into the future. The research we're doing here to understand the processing, properties and structures of those glasses and their corrosion will ensure that they're up to that challenge.